In my last video, I taught how to find imaginary numbers, how they relate to graphs, and how to plot them on a number line. But that's the equivalent of teaching like a kindergartner how to count and just leaving it there. No, I want to do math with complex numbers. So let's start doing some math with complex numbers. Let's see what sort of things we can find and do with them. Say for example, if we had 3i plus 2i, now what would that be equal to? So while I technically is not a variable, it is a number, square root minus 1, we can treat it like one and just combine like terms. This would just be, well, 5i. The reason we can combine like terms is because it's a radical, right? When we have numbers connected to a radical, like say for example 2 root 7, we added it to, I don't know, 3 root 7. That would just be 5 root 7. Because these two terms are being divided by such. So, I mean, you can just take it out, keep them there, combine like terms. So yeah, that is how we can do that with that. So I'm gonna get rid of this one, and let's see what else we can do. Our next question, let's do 3 plus 2i minus 4 plus I. Now we have two imaginary numbers, one being subtracted from the other. Now let's try and solve with this. So we have the minus out here. Now when the minus is being next to a parentheses like this is just minus 1. We have to distribute that inside. So let's rewrite this without the parentheses. This is just 3 plus 2i minus 4 minus I. And from there we can combine like terms. 3 minus 4, that's going to be minus 1. And 2 minus 1, remember, we're just combining like terms here. The I, we can just cover it up when we're doing that. 2 minus 1 is just going to be 1. So our solution is going to be minus 1 plus I. Neat. Now for our next problem, I'm going to move this right here. Next problem is going to be 3 minus 7i squared. Now we're working with squares. Let's see what we can happen here. So when we're squaring a term within parentheses, that is this term multiplied by itself. So this is the same as 3 minus 7i times 3 minus 7i. And now here we can distribute. So 3 times 3, that's going to be 9. 3 times negative 7i, well, 3 times negative 7 is 21, or negative 21, so that'll be minus 21i. Negative 7i times 3, we just did that, so that will be negative 21i. And then negative 7i times negative 7i, well, that's just a squaring of it. So we're going to multiply negative 7 times negative 7, which is going to be 49 times I squared. Now we can just simplify. So combining like terms, this is just going to be minus 42. 42i plus 49i squared. Now, are we finished? No, we are not finished. Funnily enough, this looks like a quadratic, but remember, I is a number, right? It's not a variable. We're not done. Recall, I is the square root of minus 1. So if we were to square I, square both sides, cancel, cancel, I squared is equal to negative 1. So this, in truth, is 49 times negative 1, negative 49. So 9 minus 42i minus 49. We can combine our like terms again. What is negative 49 plus 9? That is just negative 40. So our solution to this problem right here is going to be negative 40 minus 42i. Voila. Now, as we solved here, we squared I and got minus 1. But what happens if we keep on adding powers to it? What happens if we add I cubed? So we have I to the first power. Well, that is just itself. Square root minus 1. I to the second power, we established that it's just going to be minus 1. But if we had I cubed, for example, well, that is just I squared minus 1 times I again. So minus 1 times I, and that is just minus I. Now, if we did I to the fourth power, I cubed adding another I. So that is 2i squareds, which are negative 1. Negative 1 times negative 1 is positive 1. And then if we were add to a fifth power, well then that's just I times 1, which is just I. It is a cycle. So say for example, if we had a problem, let's take, I'm just going to do this one over here, I to the 26th power. That's the number 1. Firstly, I want to find this number and what is its closest, what number is it closest to that is divisible by 4? If we find the closest number that is divisible by 4, then it's just going to be 1. Is this close to 1? 24 is extraordinarily close to 26. In fact, it is 2 integers away. And 24 is divisible by 4. So this is if I to the 24th power, that is a grouping of several I to the 4th power. So I to the 24th power is just equal to 1. So now that we know that, we can just ignore 24 of these i's. This is just I to the second power. Because we have the 24 i's, which are just 1, so we can ignore them. We can forget about it. So this is just I squared, which we have established right here is negative 1. Pretty neat. Next question is over here. What was it again? 3 plus 2i times 5 minus 1 minus 5i. Is that correct? Yes. And so we will distribute again. I'm going to draw another line here to show that they are separate. Distribute once more. 3 times 1 is going to be 3. 3 times negative 5i, that's going to be minus 15i. Now we're done with our 3's. 2i times 1, well, okay, that's just 2i. And then 2i times a negative 5i, that will be negative 10i squared. Did I do that right? 3, 2, 2. Yeah, what's going on? So, combine like terms. Negative 15 plus 2, just bring it closer to the number line by 2 spaces. So that's just going to be negative 13i, and I squared, that's just negative 1. So cancel, cancel. So in truth, our solution is going to be 3 minus 13i plus 10. So it's just 13 minus 13i. Pretty neat. Now, we're getting dangerously far away from everything. I'm going to move the camera angle a little bit. Let's move the camera a little bit. There we go. We were getting very close to the end, and I feel like it was getting really cramped. So, the final question. Now that we can do all these operations with complex numbers, I'm just going to do this again. Let's try finding the complex roots of a polynomial that does not touch the x-axis. So given another function, f of x is equal to x plus 2 squared plus 6. Finding the zeros, we plug in 0 for f of x. So 0 equals x plus 2 squared plus 6 minus 6 minus 6. Of course, we want to get it over to the other side. Minus 6 is equal to x plus 2 squared. And now we can square both sides. Or square root both sides. Square root and the square cancel. Then we have square root minus 6. Well, like we did last video, we can split this radical to square root of 6 times the square root of negative 1, I. So square root minus 6, or plus or minus square root minus 6, is just going to be plus minus root 6i is equal to this right here, x plus 2. And now, one more step to get x isolated. We're going to subtract 2, and then we are done. We have x is equal to negative 2 plus or minus square root of 6i. Pretty neat. Now, while we cannot show this on a regular graph, let's try plotting this on the number line we created last video. If you forgot, or if you didn't watch it, the number line looks very similar to a graph, except this is going to be our complex part, our complex number line, and the horizontal is going to be our real number line. And so, like we did before, minus 2, we want to go back 2 spaces. It joins at 0, right? So we're going to go back 2, minus 1, minus 2, and plus and minus root 6i. Root 6, I don't know that off the top of my head, but I know that is between 4, or I know root 6 is between 2 and 3, because root 4 is 2, root 9 is 3, so I'm just going to say 2.12, whatever. So we're going to go up 1, 2, and then a little bit after, I'm just going to say like right here, dot, 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 and then we're going to say that is our 1 point. Now that was the plus part, now we're going to do the minus part. We're going to go down 2 imaginary spaces, a little bit over, bring it over, and then here we have our 2 imaginary complex numbers. So this one right here, that is going to be our minus 2 plus root 6i. And then this is going to be our minus 2 minus root 6i. I wrote that diagonally. So yeah, complex math. It's no calculus, but yeah, imaginary numbers, very cool thing, and I think it's great to introduce, students who aren't particularly into like the deep end of math yet, into something that is complex. Because obviously this is not real numbers. This is the first time they've been introduced to something that, you know, you can't physically grasp, you know. So if you don't really like get it, I hope this was a nice way to review, perhaps learn, and even my last video might have helped with that. So yeah, thank you for watching. Complex Math, go!